Today, the topic is about Corten steel. And I'm going to tell you why this steel rusts on purpose. Hey, engineering guy! Have you ever walked past a modern building, an impressive bridge, or even a sculpture in a public square and wondered why that structure seemed to be completely covered in rust? At first glance, anyone's natural reaction is to think that there was a maintenance mistake or that the material is dangerously degrading. However, in most of these cases, what you're seeing is one of the most fascinating and intelligent materials in modern metallurgy, Corten steel. But how can metal be specifically designed to oxidize and still be considered more durable than regular steel? And why would engineers and architects choose a material that looks like it's deteriorating to support structures that are supposed to last for centuries? To begin with, we need to define exactly what this material is. Corten steel is not just ordinary steel that's been left out in the rain. It's a category of structural steels known as weathering steels. The name Corten is actually a registered trademark of the United States Steel Corporation. In fact, their headquarters building in Pittsburgh is constructed using Corten steel, which got its name from the combination of two of its main properties: corrosion resistance and tensile strength. Originally developed in the 1930s for coal transport wagons, the goal was to create a material that could withstand abrasive wear and corrosion without the need for constant painting. But have you ever wondered how an industrial innovation for freight trains ended up becoming a staple in luxury architecture and in heavy civil engineering? The answer lies in its unique ability to self-heal and create a protective barrier that eliminates the need for external chemical treatment. Something that revolutionized the way we think about the longevity of metal structures. The real magic of Corten steel happens at the atomic level through a very specific recipe of chemical elements. While regular steel is basically made up of iron and carbon, Corten gets strategic additions of other metals. Among the main ingredients are copper, chromium, nickel, and phosphorus. But what is the function of each of these elements in the mix? Copper is mainly responsible for helping the rust layer adhere, preventing it from coming off. Chromium and nickel increase mechanical strength and help in the formation of more stable oxides. Phosphorus, on the other hand, helps in creating a denser initial layer. This combination is not random, it is calibrated so that when the metal is exposed to the environment, it reacts in a very different way from pure iron or steel. Can you imagine that small amounts of these metals, often less than 2% of the total composition, are capable of making such a change? Change the fate of a steel beam in the sun and rain. It's a chemical precision that separates material that rots from material that matures. Now let's understand the chemistry behind this phenomenon. When conventional steel is exposed to moisture and oxygen, the oxidation reaction occurs. The fundamental chemical reaction can be represented by the formula on the screen, where iron reacts with oxygen and water to form what we know as rust or iron hydroxide. In common steel, this iron hydroxide turns into a layer of hydrated iron oxide, as shown on the screen, which is extremely porous and brittle. But in Corten steel, the process takes a different direction. Instead of creating this fragile flaking layer, the presence of the alloying elements causes the corrosion products to form a dense and compact structure called patina. This patina is composed of a complex mixture of oxides, mainly iron oxide, copper oxide, and chromium oxide. But why is this mixture so superior? Unlike common rust, this patina is practically impermeable. It seals the pores on the surface of the metal, preventing oxygen and water from continuing to penetrate the inner layers. It's as if the steel is creating its own natural and permanent layer of paint. To better visualize the advantage of Corten, imagine two metal sheets exposed to the weather, one made of regular carbon steel and the other made of Corten steel. On the regular sheet, rust acts like a sponge, holding moisture against the metal and accelerating the degradation process until the piece loses its structural integrity. On the other hand, with the Corten sheet, after the first few months of exposure, the formation of stable oxides interrupts the corrosion cycle. But here's the catch. This protection is not instantaneous. Corten steel needs to go through cycles of wetting and drying so that the patina develops properly. If the steel stays constantly wet, it won't be able to form the protective barrier and will end up behaving like regular steel. On the other hand, when properly formed, Corten has a corrosion rate up to 8 times lower than that of conventional steel. This means that, as an engineer, you need to build in a large corrosion allowance or use extremely expensive coatings. Compared to regular steel, Corten allows for slimmer and longer-lasting structures with less maintenance effort. But with such impressive properties, where exactly do we see Corten steel in action? In civil engineering, it is used in bridges and viaducts, where maintenance and painting would be logistically difficult and extremely expensive. A classic example is the New River Gorge Bridge in the United States, which uses the material to avoid the need for periodic painting at a height of almost 300 meters. In architecture, the material is chosen both for its durability and for its industrial and organic aesthetic. Buildings like the Barclays Center in New York use Corten panels to create a facade that changes color over the years, evolving from bright orange to a deep earthy black-brown. But have you ever thought about the environmental impact of that choice? By eliminating the need for paints, which often contain volatile solvents and heavy metals, Corten steel presents itself as a much more sustainable option for large urban projects. It is a material that accepts the passage of time and uses it to its advantage, integrating perfectly with the landscape. However, even though it may seem like a miraculous material, Corten steel is not indestructible and requires specific design considerations. Do you remember that we mentioned the need for drying cycles? Well, if Corten is used in places where water pools or is in constant contact with damp soil, the protective patina does not stabilize and the metal will continue to corrode until it fails. Another critical point is the marine environment. In regions very close to the sea, the excess chlorides in the air can prevent the formation of a stable protective layer of iron oxide, making the use of Corten risky without additional protection. In addition, there is an aesthetic detail that can be a problem: rust runoff. During the first years, while the patina is forming, rain washes away small oxide particles, which can stain concrete sidewalks or light-colored stones around the structure. Engineers usually design specific drainage systems or use gravel bases to hide these initial stains until the steel reaches its chemical maturity. Beyond its technical functionality, Corten steel carries a very strong symbolic value in contemporary design. It is a material that is alive because its appearance is dictated by the weather, sun exposure, and the humidity of the place where it is installed. A Corten facade in a coastal city will have a different tone from a facade in the desert. Architects use this rough texture and the color variations to create contrasts with glass and concrete, bringing a sense of warmth and naturalness to cold urban environments. If you've made it this far and enjoyed the video, take a moment to subscribe if you haven't already, leave a like, and turn on the notification bell. And if you find our content interesting, consider becoming a member to help us keep producing content here on the platform and be mentioned in our videos. If you've made it this far, I invite you to take a look at the courses we recommend. So point your phone at the QR code or click the link in the description for our courses. There you'll find courses on Excel, 3D modeling, AutoCAD, public speaking, and many others. These are courses selected by us here on the channel, and we can vouch for their quality. And you, what do you think about this engineering approach? Do you prefer the flawless perfection of painted steel or stainless steel, or the rustic and functional beauty of Corten? Have you ever seen any famous structure made with this material that caught your attention? Leave your opinion here in the comments. I want to know. Right over here are two interesting videos that you need to watch to expand your knowledge and explore your curiosity. And if you want to support us, leave a like, subscribe to the channel, turn on the notification bell, and consider becoming a channel member. That's it, engineering lovers. Take care, and I'll see you in the next video.